This is geotrig lesson 1 again. I think we're on our 5th day on this. And we're still going to have some more for tomorrow. This first group is area and perimeters of triangles. And so, how do we calculate the area of a triangle? We talked about triangles yesterday of the isosceles, equilateral, scalene. But how do you find the area of one of those things? Yeah.
Length times width divided by 2.
Okay, length times width divided by 2. That is correct. But most of us probably would remember it as area equals 1/2 base times height. Length and width, it doesn't matter, guys. Length times width is the same thing as base times height. It still forms a rectangle. And a triangle is just half the area of a rectangle. There are proofs for that. I'm not going into all the proofs for those right now. We might be able to cover those later. We'll be doing proofs later. What does area tell us, though? The area, thank you. Area tells us area, guys. To jump means to jump.
How much stuff can fit in?
How much stuff can fit in? Okay. That's getting there. Space it takes up. So basically, on the screen here, we got that lit part on here. It's taking up an area. So square feet, square inches, square miles, square units. It's a two-dimensional space, right? Volume is a three-dimensional space. Volume has 3 dimensions to it: a length, a width, and a height. So it's not flat. Perimeter is blank of the shape. I'm not exactly sure where I was going for on this one.
Surround.
The perimeter is around of the shape, or the outside? Oh, outside of the shape. Maybe that's a better fit. Outside.
What does area tell us, though?
What's that?
What does area tell us? Do we just...
We talked about it. It's the space that it takes up, two-dimensional space. The outside of the shape. Or, if I want to talk about something other way, if you traverse the outside of this room, you are covering a distance, right? So how about the distance around the object? The distance around an object. I have a hard time saying this word. The synonym? No. Synonym. Synonym? Synonym. Oh. Yes.
The arrow.
The thing that, okay, better word for me would be, another way to say height is what? Vertical distance. I like that. It's got what you guys sometimes have. Altitude, you guys have an attitude, but it's close, I guess. It's an altitude. So, guys, our problems in this book are going to use the word altitude instead of height. Now, altitude is something very special because if you have a triangle, as you can possibly picture something like this, that's a triangle, right? The height is not in the middle. Can you guys agree with this? It's like not directly in the middle. Sometimes the height can be outside of the triangle too. So if I had a triangle that was like this, the height is actually not even inside at all.
That's true.
And so when we say drop in altitude, it actually means go from the highest peak straight down, forming a right angle with the ground or the base. So this one, you would have that dotted line, and you would drop straight down from there. Do you guys kind of picture that? This should be dotted. That didn't come through on the screen very well. And that would be your altitude. So altitudes, when you have them on a graph, form 90 degrees with the base. That's important. It's good to know. Because you look at part 4, which is the actual example, you need to answer the question of find the altitude of the triangle. You are given an equilateral triangle, keyword equilateral, that has a perimeter of 24 meters. It also has an area of 16 times the square root of 3 meters squared. Keyword there was equilateral, perimeter, area. How do I link some of these, or what should I do? Hint, ladies and gentlemen, if you think that you're going to make it through this book by looking at sentences like that, and you're just going to be able to find an answer, you're in the wrong. You're going to need to draw a diagram to go with it. There are going to be problems that are going to be very hard without a drawing. And so, what's an equilateral triangle look like? All equal sides. Something really close to that. It's kind of like the perfect triangle, yeah?
Like a Dorito.
Okay. Now, if that equilateral triangle has a perimeter of 24, doesn't that tell us something too? What does it tell us? Each side is 8. 8 meters, right? Because the total perimeter was in meters. I'm leaving the meters off because I can put that on later. We also have an area that is 16 square root of 3 meters squared. Do we have a connection then? Or can we assume something about that equilateral triangle? Pete?
I don't need to know area of triangle. I can just count with the perimeter of sides.
Say that again. Now, there has to be a connection. There has to be a reason that we have all these 8s. But here's a question. Watch what I can do here. Right now, what's the base of this triangle? 8. Let me try this. What is the base of that triangle? Oh, what is the base of that triangle? It's infinity, guys. Look, it's sideways. But that's not the one we were talking about. We're talking about this guy right here, right? Either way, it's 8. So wait a minute. You know an area. You know a base. The one thing we're missing is the altitude or height. So, could there be a reason why they're giving me the area and a base? It's because I'm probably going to use this guy right here, right? There's a formula for that. Anytime you guys use a formula, you're going to write it down. And fill it in. What's the area?
16 times the square root of 3.
16 times the square root of 3. What's a half? A half. What's the base?
8.
What's the height? H.
We don't know the height.
It's H.
I know.
Height is height.
Oh, I thought you said 8.
How many variables are left?
1.
Can you solve for H?
I think you can.
What's a half of 8?
4.
4H. To get H by itself? divided by 4. Do not take your calculator out and put 16 times the square root of 3 and then divide by 4. It'll work. But you're going to have this weird, obscure decimal. Right? Because square root of 3 is not a nice number. But 16 divided by 4 is a nice number. What is that? So that means h is equal to 4 times the square root of 3. Just reduce the fraction. Leave it as an exact answer. Now, Monica, can you do me a favor and do 4 times the square root of 3? Because it looks like you're the only one who has a calculator out. That's on the video. I said do not put it on the calculator. I didn't say they don't have one out.
So we're
What?
not going to give it popcorn. I wasn't asking.
Okay. 4 times the square root of 3. Guys, we're recording. So, should be 5 or 6 something, 6 point. Doesn't want to work. Okay, hold on. So, we found it out to be 6.93, la-di-da-di-da-di-da. We rounded it here. This is an approximation, guys. Approximation versus exact. If you were to look in the answer in the back of the book, they will use exact unless they ask you for an they'll use an approximate. Wow.
What?
Let me rephrase this. They're going to ask for the exact answer, which is 4 times the square root of 3, unless they ask for an approximation to the hundredths or 2 decimal places. Okay? Does that make sense?
Yes.
Okay. Now that we got that taken care of, now we can do this. Now we're going to talk about transversals, alternate, and corresponding angles. Remember that. Now, this is the whole zigzag parallel line stuff, guys. We should like these because a lot of things are equal. A blank is a line that cuts or intersects one or more lines in the same plane, basically on the same piece of paper, on the same board.
Transversal.
Transversal, yes, thank you.
Well done.
Oh.
Transversal. I'm not writing that in there. But transversals are lines that cut or intersect one or more lines. Okay? So if you look here, line T is a transversal to line 1 or L1 and L2. Are you guys okay with that?
Yeah.
If the blank cuts through parallel lines, what cuts through lines again?
Transversal.
Oh, this guy? Transversals. I'm lazy today. And so if the transversal cuts through parallel lines, blank and blank angles are formed.
Alternate corresponding.
How did you figure that out?
It's the title.
It's the only 2 words left in the title, guys. Alternate and corresponding angles are formed. Where are those alternate and corresponding angles being made up? Right here. Parallel lines. L1 and L2 are parallel. Cut by the transversal T.
Yep.
Hey, there's some really cool things, guys, that you guys already know. Like, angle 1 and angle 3 are the same because they are vertical angles. That means 2 and 4
2 and 5 and 7 and 6.
are vertical angles. And yes, Mike, 5 and 7 are vertical angles. 6 and 8 are vertical angles. They are all the same to each other as a vertical angle. Yes?
Yeah.
Yes.
Now, it asks you to look at this diagram and make some conjectures, make some hypotheses, make some connections. 1. Doesn't 1 look really close to 5? Did- Doesn't it look like the same angle?
Yeah.
What about 2 and 6?
Yes.
I'd say they're pretty close.
Yeah, it's got a name, guys.
What's the name?
The name for 2 and 6, 1 and 5, or 4 and 8, 3 and 7, Those are called the corresponding angles. Corresponding angles are ones that, imagine I'm able to pick up angle 1. I pick it up. Could I drop it on angle 5, and would you even tell a difference? No. They correspond to each other. So therefore, 4 and 8 also could be picked up and dropped on the top of each other, right? Those are corresponding angles. Got a question. We just said before, 1 and 3 are equal.
Yeah.
We also just said 1 and 5 are equal.
So 3 and 5 are equal.
So by the transitive property, if 1 is equal to 3, and 1 is also equal to 5,
3 is equal to 5.
so 3 has to equal 5, yes?
Yes.
That is true. There's a special name for that.
Alternate angle.
Alternate, because they're on opposite sides.
Exterior.
They're inside, so they're alternate
Interior.
interior angles. So down here, second set of blanks. Alternate interior angles. 3 and 6. Ooh, those are, we didn't do those ones yet. We didn't talk about those. 2 and 8. Wait, is 2 and 8 the same? They appear to look the same. But 2 is equal to 4, right? 8 is equal to 6. And 4 and 6 are the same because that's alternate interior. Then 2 and 8 are called alternate
Exterior.
exterior. So we got alternate exterior. We got alternate interior. We got corresponding. We got to go back to 3 and 6. Oops. What did I just do? Okay, I'm going to take the lines out. 3 and 6. 3 and 6 are these guys right here, right?
Yes.
Those are called
No.
not corresponding. Consecutive angles. Consecutive angles actually add up to 180. So add to 180 degrees. Now, I'm going to take that circle out of there. I had that zigzag pattern that was approximated to Harry Potter's forearm. And, scar. I thought he had a scar on his forearm. Forehead. But look, is there a reason why I chose 1, 3, 5, and 7?
Because they're odd.
They're all odd numbers, and they're all the... How about 2, 4, 6, 8?
Same.
You got a double helix going on there. You guys are made up of all that stuff.
Why?
So, does that make sense, guys?
Not a theory. Jesus.
Yeah, DNA is not a theory at this point anymore. Are we good to go with that, guys?
I think so, yeah.
Yes.
That's as far as I got with the other hour.
Okay.
So your homework. Lesson 1, day 5. Still page 12. I forgot to put page 12.
Are we just going to do all
15, 21, and 27. Have a great day.